Hello everyone, once again I am back with a new video. My name is Ria Rahul Chaudhary. I am pursuing my B.Ed from AGS College of Education. My today video is on the subject of mathematics, and today's topic is exploring the basics of geometry. Points, lines, curves, and their properties. So, here we're going to be exploring related to the basics of geometries. So, here first, the history of geometry. The history of geometry dates back to ancient civilizations, with the earliest known use by the Egyptians for land surveying and the construction around 3000 BCE. The Greeks, particularly Euclid, formalized geometry as a mathematical discipline in the 4th century BCE, compiling his work in the Elements, which remained influential for centuries. Indian mathematicians like Aryabhatta and Bhaskara also significantly contributed to geometric concepts, particularly trigonometry and astronomy. In the Islamic Golden Age, scholars like Al-Khwarizmi and Omar Khayyam expanded on Greek and Indian geometry, further developing algebraic methods to solve geometric problems. By the Renaissance, European mathematicians such as Descartes and Fermat introduced coordinate geometry, merging algebra with geometric principles, which laid the foundation for modern geometry. So, this was a small history related to the geometry, the earliest geometry. Then comes the definitions of basic geometric terms, which we're gonna be seeing in the further upcoming slides. So here first the terms are points, line segment, line, ray, parallel lines, perpendicular bisector, intersecting lines, and point of intersection. So here comes the definition. First is the point. A point is a location in space that has no size, shape, or dimension. It is usually represented by a dot and named with a capital letter. Line segment. A line segment is a part of a line with two definite endpoints. It has a fixed length and is the shortest path between the two endpoints. What is a line? A line is a straight, one dimensional figure that extends infinitely in both directions with no endpoints. It is usually represented with arrows on both sides. So a point is what? A point is what it shows or represent what location in a space, and it has no size, no shape, no dimension. Line segment is what? It has to endpoint, it has a fixed length. What is line? It is represented by arrows on both the sides. It shows the direction. Then comes the topic ray. A ray is a part of line that starts at a point and ends infinitely in one direction. Parallel lines are the lines two or more lines in the same plane that never intersects, no matter how far they are extended. So parallel lines never cross or meet each other. Perpendicular lines are two lines that intersect at a 90-degree angle. Then comes intersecting lines. Intersecting lines are the two lines that cross each other at a common point. What is point of intersection? The point of intersection is the point where two or more lines meet or cross each other. Through example, we can see two lines are meeting each other at a common point O, and that point is said to be as point of intersection. So now we'll see what is a curve and its types. So first is the definition of the curve. A curve is a continuous and smooth flowing line without sharp angles. They bends and changes direction. Unlike straight lines, curves can be open or closed and vary in shape and length. So a curve is what? It is a smooth flowing line where its angle is not sharp. It is kind of bended. So here are the different types of the curve. They are as mentioned below: simple curve, open curve, closed curve, non-simple curve, concave curve, convex curve, plane curve, space curve, and then comes the smooth curve. So here types of the curves. First is what is simple curve. A curve that does not cross itself, it may be open or closed. For example, a semicircle or an arc. So a curve that does not cross itself, it may be open or a closed. So it's said to be a simple curve. Here we can take example as U, M, S, C as a simple curve. For open curve, a curve that does not form a closed loop and its endpoint do not meet. It means it's not a closed figure. So here you can take the example same as simple curve C, S, M. Now comes closed curve, a curve where the start and the end points are the same, forming a closed loop. So here you can see the starting and the ending points are same, means meeting to each other, and a closed figure is formed. But under the closed curves, the curve shouldn't form a perfect angle. So here triangle in the given figure is not a closed curve. Make sure that. And the moon should will be okay. Consider, but make sure the angles are little bit more banded. Not a proper pointed angle shouldn't be forming. Now comes simple closed curve. A closed curve that does not cross itself. It means a figure will be closed and that figure shouldn't cross to itself. So here it's said to be as a triangle or a square, but it won't come under this is a mistake over here because a curve can be as you can take circle or some other way of examples can be considered. From the below diagram, you can see simple closed. Then comes non-simple curve. A curve that crosses itself at one or more points. So here a non-simple curve, it means a figure which is crossing itself. So below you can see the diagram. There comes the concave curve, a curve that bends inward with no part of it sticking outward. So a crescent moon shape. Then comes a curve that bends outward with no part curving inward. Now here the example is the outer boundary of a circle or a sphere. Plane curve, a curve that lies entirely in one plane. Example, a circle drawn on sheet of a paper. Then comes the space curve, It means a curve that does not lie in a single plane but extends in three-dimensional space. Example, a helical curve or a spiral staircase. Then comes smooth curve, a curve that has no sharp turns or breaks with a continuously changing direction. So here the example can be taken as a sine wave or the shape of a bell curve. Then comes a new topic is about the positions of the point in a curve, like where the points can be placed in a given curve. So here first is the interior points. What is interior points? The points that lie inside the curve where every point is completely enclosed by the curve. For a closed curve, the interior points are all those that are not on the curve itself, but are contained within it. So for a circle, all the points within the circular boundary but not on the circle itself are interior points. So from this we get an idea that the points lying inside within the given curve is an interior points of a given closed curve. Then comes the exterior point. So here exterior points are the points that lie outside the curve. These points are not enclosed by the curve and no part of the curve passes through them. For example, the same circle, all the points outside the boundary of the circle are exterior points. So in the given figure, you can see the given curve is represented by the greenish line. Outside the given figure, there is point B, and the point B is called exterior points. Then comes boundary points. Boundary points are the points that lie on the curve itself. They separate the interior points and from the exterior points. In the case of a simple closed curve, all points on the curve are boundary points. So for here example, for a circle, the points on the circumference of the circle are boundary points. Lower the diagram, the picture you can see, the first figure shows the interior points. Interior means within the closed curve. So within there is a point L and A. Exterior point outside the closed curve, that is point G. Points on the circle means boundary points, and on the circle you can see NICE. So here I conclude my topic with that in geometry, fundamental concepts such as points, lines and curves form the basics for understanding shapes and spatial relationships. Curves can vary from simple to complex, and their properties, like interior, exterior, and boundary points, help define their structure and position in a plane. Understanding the distinctions between this point is crucial for analyzing closed and open curves and their interaction with space. These concepts are widely applicable across geometry and other fields, from basic shapes to complex mathematical models. Overall, mastering these basics provides a strong foundation for further exploration in mathematics and its practical application. So, with this, I conclude my topic, and I will all again just have a look on all the points we have seen over here. So, here let's get back to the first slide with the topic. The topic was exploring the basics of geometry. points, lines, curves, and their properties we see in the history of a geometry. Different important definitions of basic geometrical term with the given figures side by side. Then comes the what is curve and its different 10 types of the curves. These are all the definition with diagrams. Then the composition of points, which we have seen three position of points: interior, exterior, and boundary points. So with this, I'm really thankful for everyone for I hope everyone understood this topic, and I would like to once again say you thank you for watching my video.